This whole blockchain thing.
Okay.
I know. For a lot of people, it's one of those terms you hear and your brain just kind of shuts off. But
Yes.
trust me, it's actually pretty fascinating stuff once you get past the buzzwords and all that.
Right.
Like, have you ever wondered how it actually works, beyond just like Bitcoin and all that?
Definitely. Yeah.
So we've got a stack of slides here from a presentation on blockchain and DLT, that's distributed ledger technology, just in case you were wondering.
Okay.
And they're going to help us break it all down, hopefully in a way that even I can understand.
Well, I'm sure you'll get it.
So where do we even start with this?
Well, I think the coolest part is that we're really talking about a totally new way to think about keeping records, right? Like, imagine instead of having one central database, like, say, a company's main computer system, you've got information spread across tons of different locations.
Okay.
And that's essentially what distributed ledger technology is, like in slide 4.
Like that scene in sci-fi movies where they're like, we've got the data backed up in 3 different off-world locations.
Exactly. Well, maybe less dramatic. Hopefully no evil empires involved.
Yeah, let's hope not.
But yeah, the core idea is similar.
Okay, so that's DLT, but where does blockchain fit into all of this?
Right. So blockchain is a specific type of distributed ledger.
Okay.
It's like, imagine a digital record book, right? Every time something happens, a transaction, an update, anything, it's like adding a new line to that book.
I'm with you so far.
Now, here's where it gets interesting. Everyone in the network has a copy of this book.
Oh, wow.
So it's totally transparent, like no more shady dealings in the back room because everything's out in the open.
I like the sound of that.
And each new line, each new record, it's linked to the one before it using something called a cryptographic hash function, which sounds complicated.
Yeah, a little bit.
But it's basically like a fingerprint for that specific piece of data.
Okay, so like if you were to look at slide 10, you can kind of see it visually.
Exactly. And if you change even one tiny thing in that data, you get a totally different fingerprint.
So it's tamper-proof, basically.
Exactly, which is a big part of why blockchain is considered so secure.
That makes sense, yeah.
Yeah. And then there's how new information actually gets added to the chain.
Okay, how does that work?
So let's say you want to make a transaction. That request is packaged up into what's called a block.
Okay.
And then it's broadcast out to the entire network.
So like it's sending out a mass text saying, hey, everyone, check out this new entry for the record book.
Exactly. Those texts go out to special computers on the network called nodes.
Okay.
And it's their job to verify that the transaction is legit, following all the rules of the blockchain.
Sounds like a massive peer review process or something.
Exactly, making sure everything checks out. And once the nodes give the thumbs up, the block is added to the chain.
Okay.
And it's permanently linked to all the blocks that came before it.
So that's what makes it so hard to tamper with, because you'd have to change every single block on every single computer all at once.
Exactly. It's practically impossible.
Wow.
And this is essentially how blockchain 1.0, the first generation of this tech, really came about.
Okay.
It was all about cryptocurrency, with Bitcoin leading the charge.
Right.
And the whole point was to create a decentralized peer-to-peer network for digital money, like it says on slide 8.
So no banks, no governments, just pure digital transactions.
Exactly. All secured by this, amazing blockchain technology.
And to keep everything running smoothly, they came up with this whole proof of work system, right?
Yeah, it's actually pretty ingenious, as you can see on slide 9. Basically, it's like a giant digital puzzle that those nodes we talked about have to solve in order to add new blocks to the blockchain.
And solving that puzzle requires a lot of computing power, which I'm guessing is where you get into the whole, like, Bitcoin mining using tons of electricity thing.
Yeah, exactly. It's like a deliberate bottleneck designed to make it incredibly difficult and expensive for anyone to, try and take control of the network.
So they would have to outcompute everyone else, which would just cost a fortune in electricity.
Exactly. It's a really clever way to ensure the security and integrity of the system.
Okay, that's really interesting. So we've got this secure tamper-proof system, but like any technology, it evolves.
Of course, it doesn't just stop there.
Right, so what came next?
That's where blockchain 2.0 comes in, bringing even more cool features. And one of the big ones is smart contracts.
Okay, I've heard that term thrown around, but I'm not entirely sure what it means.
So basically, smart contracts are lines of code that automatically execute an agreement when certain conditions are met. Kind of like, think of it like a vending machine, but for digital agreements.
So you put in your digital tokens and boom, contract fulfilled, no middleman needed.
Exactly. And that opens up a ton of possibilities beyond just cryptocurrency.
Yeah, like suddenly we're not just talking about, digital money anymore. I
Right.
mean, slide 12 even mentions things like supply chain management, voting systems, like
Mhm.
even identity verification.
It's
Like
wide.
blockchain, finished school, got its diploma, and now it's ready to like go out and get a real job.
Uh-huh.
So
Exactly.
how does that even work? How do you get from like digital money to all of that?
Well, that's where this idea of programmability comes in,
Hmm.
which slide 12 actually does a good job of explaining.
Okay.
Basically, it means that developers can actually write code that interacts with the blockchain directly.
Okay.
So they can build all sorts of applications on top of it.
So it's like giving everyone the tools to create their own like blockchain powered solutions.
Yeah, exactly.
So you want to like build a decentralized marketplace for your, I don't know, your neighborhood or something.
Yeah, or like track the origins of your food from farm to table, all that kind of stuff.
Well, that's actually pretty cool.
Yeah, and it's not just about, practicality and stuff.
Good.
Blockchain 2.0 also saw this rise of tokenization, which slide 13 talks about.
Okay, so tokens, like what? Like Chuck E. Cheese tokens.
Haha, not quite.
Okay.
But I see what you're getting at. Basically, it means creating digital tokens that can represent all sorts of things, right?
Right.
So instead of just having Bitcoin, you could have tokens that represent, I don't know, shares in a company or like loyalty points at your favorite coffee shop.
Oh, that's interesting.
Even ownership of digital art, like it can get pretty wild.
Yeah, so it's like the Wild West, but like for digital assets.
Pretty much, yeah. And of course, with all this innovation comes new challenges, right?
I was just going to say, there's got to be a catch.
Oh, there's always a catch.
Right.
So remember, proof of work, that whole energy-intensive process for adding new blocks to the blockchain.
Yeah, like how much electricity it takes to mine Bitcoin and all that.
Exactly. So Blockchain 2.0 started exploring different approaches, like proof of stake, to address that.
Okay, so proof of stake, is that like less energy consumption then?
Yeah, it's way more sustainable.
Okay, so that's good. Saving the planet, one blockchain transaction at a time.
Exactly. And it works a bit differently. So instead of just brute computing power, right?
Yeah.
Proof of stake selects validators based on how much cryptocurrency they've staked,
Okay.
or basically how much they've put up as collateral.
So it's like saying you get a say in how things run based on how much you've invested in the system.
Exactly. It's all about aligning incentives.
Okay, that makes sense. So what's the downside?
Well, as slide 13 kind of hints at, there are some concerns about security with proof of stake.
Oh, really? Like what?
Some people think it might be more vulnerable to certain kinds of attacks.
Interesting. So it's like better for the environment, but maybe riskier in other ways.
It's a trade-off for sure.
Isn't that always the way with technology, though? You fix one problem, and then 10 more pop up.
Haha, pretty much.
So where does that leave us now with blockchain, I mean?
Well, that brings us to the cutting edge, the bleeding edge blockchain 3.0.
Ooh, blockchain 3.0. This sounds serious.
Oh, it is. And slide 14 really lays out the vision.
Oh,
It's all about tackling those limitations of the previous generations.
like what?
We're talking about making it faster, more scalable, and even more interconnected than ever before.
It's like blockchain went back to school for like a PhD or something.
Haha, something like that.
So what can blockchain 3.0 do that, 2.0 couldn't?
Well, for one, imagine if different blockchains could actually talk to each other seamlessly.
Oh, that's interesting.
Right. That's the whole idea behind cross-chain connectivity, which slide 14 mentions.
Yeah.
And there are projects like Polkadot and Cosmos that are working on making this happen.
So no more like blockchain islands all walled off from each other.
Exactly. It's about building bridges between all these different digital worlds.
I like it. So it's like, what, you can trade, I don't know, your coffee points for like digital art or something.
Exactly. It opens up a whole world of possibilities. And blockchain 3.0 doesn't stop there. Slide 14 mentions directed acyclic graphs, or DAGs for short.
DAGs, okay, that sounds pretty technical.
Yeah, it is a bit, but in simple terms, DAGs are being explored as a potential alternative to the traditional blockchain structure.
Right.
And they offer some intriguing advantages in terms of speed and efficiency for processing transactions.
So it's like blockchain is getting a performance upgrade.
Yeah, you could say that. Blockchain developers are always looking for ways to improve the technology, make it faster, more efficient.
Right.
And a big focus, which you can see on slide 15, is usability.
Okay, so making it more user-friendly.
Exactly. Because right now, it can be pretty intimidating for the average person.
Yeah, I'd say so.
So the goal is to make it accessible to everyone, not just, the tech-savvy folks.
Yeah, that makes sense. Kind of like how the internet used to be, right?
Yeah.
You needed to know how to code to even make a basic website.
Exactly, but now anyone can build a website with just a few clicks.
Right, and now look at it. Everyone's online.
Exactly. And it feels like blockchain is on that same trajectory.
Okay, so big potential then.
Huge potential, especially as we see more real-world applications popping up, like Slide 16 has a whole bunch of examples.
Yeah, it's like everything from finance and healthcare to, what is that, supply chain management.
Yeah, even the automotive industry is getting in on the action.
Wow, so blockchain really is, like, poised to touch, like, almost every part of our lives.
It seems that way, and that's both exciting and a little bit daunting, to be honest.
Yeah, slide 18 kind of touches on that, right?
Exactly. It's not about saying that blockchain is, a magical solution to every problem.
Right.
It has its strengths and its weaknesses, and we need to be mindful of both as we move forward.
So it's not a silver bullet, but it's still a pretty powerful tool.
Exactly. It has the potential to revolutionize a lot of industries and systems, but we need to be thoughtful about how we use it.
Absolutely. Well, on that note, I guess it's up to all of us to keep learning and exploring this whole blockchain thing.
I agree. The technology is constantly evolving.
That's for sure.
And who knows what incredible innovations the future holds.
Exactly. Well, hey, thanks for breaking it all down for me and for all of our listeners out there.
Of course, happy to be here.
Always a pleasure. And for everyone listening, thanks for joining us on this deep dive into the world of blockchain. We'll catch you next time.